This section is all about tangent lines, how to know if we have one, and then how to determine angles that are created by them. This one will be quite a bit shorter than the last section, so those of you who struggled might enjoy this set a little bit more. It will be less in depth. So let's take a look. So the first thing we have to know and to write down is that if we have a tangent line, okay, the one that bumps into the circle, if we have a tangent line, then the tangent line will always create a 90-degree angle with a radius. We will always get a perfect T shape with a radius. Okay? So in order to decide if we have a tangent, we need to check to see if this is 90 degrees. If it's 90, then the line is tangent. If it's something other than 90, then the line is not tangent. Okay, so let's figure out how we do that. So how to check if we have a tangent line? We're going to use our Pythagorean converse. And so the steps are, we're going to take our picture and we're going to make a triangle. We're going to write in any lengths that they tell us. We'll find the hypotenuse. We'll find sides A and B. And then we're going to use our chart to check to see if it's right, acute, or obtuse. If the triangle is a right triangle, then the line is tangent. So let's look at an example. Okay, so here's our steps, and I've done this one for us. So number one, I made a triangle. So I made a triangle out of what I'm checking for tangent and what I think is my radius. I make a triangle. Now, if it all works out, this will be 90, which means this is my hypotenuse. This is C over here, which means these would be A and B. And so I just wrote some lengths in here. The problem will give you numbers to write in. Okay, so I would write those in. And then I set up the chart. Remember making this chart where you have C squared and A squared plus B squared, and you're going to be able to leave a space in here so that you can compare this left to the right. So in this example, the C was 25, so I have 25 to the second power. A was 15, and B was 20. So when I calculate all that out, I get 625 and 625. Those are equal to each other, so I have a right triangle. And so because I have a right angle, then the line is a tangent line. It's a true statement. It is a tangent line. Okay. So this is an example you're going to want to write down, and we'll do some more together, because in your assignment you have to check a few of these. So let's take a look. Determine if AB is tangent. So we need to decide if this is tangent. So basically, it's asking us to figure out if this is a right angle or not. Right? So we already have a triangle. So I need to decide what is my C. Right? So C would be the side away, which means these can be A and B. So I'm going to set up my chart. And I'm going to see if I have a right triangle or not. So C was 15 squared. A was 5 squared. B was 14 squared. So 15, that's 225. 5 squared is 25, and 14 squared is 196. So I have 221 over here. Okay, so I'm comparing 225 and 221. 225 is larger. This is not equal, so it's not right. Right? This is actually obtuse. So to answer the question, Is AB tangent? My answer is no, not tangent. If this had been equal, then yes, it would have been. Let's try another one. Determine if AB is tangent. So here's my potential tangent line, which means I'm checking to see if this is 90 right here. So I need to figure out C. Remember, C is going to be this whole thing, right? C is going to be this whole long side. So this is actually 20, right? It's 20 for that side. The radius is 12. 8 more is 20. So C is 20, A is 12, B is 16. So let's make my chart. So C is 20, A is 12, and B is 16. This is 400. 144, and this is 256. So I add these together and I get 400. They are equal to each other. So yes, tangent. Right? Because I have a right triangle. And that's the rule. If it's a tangent line, this will be a right angle. And so we use the Pythagorean converse to decide if we have that right angle or not. Verify if the segment is, or verify if this is tangent. So we're checking to see if this is a 90-degree angle or not. So C is this entire side, so that's 10 altogether, right? 6 and 4. The whole thing's 10. So C squared, A squared, B squared. So C was 10. We can say this is A and this is B. It doesn't really matter what order you put those in. I have 100, 36, 64. You add those together, that's 100. They're equal. So yes, tangent. Okay? Let's check this one. See if the segment is tangent. So we're going to check to see if that's 90. So this is C, A, B. 15 is the whole thing. There's no addition I have to do here. So we're going to check. Okay, so all I'm doing is squaring this. Then I'm going to add the 81 to the 144. Get 225. Compare them. They're equal. So yes, tangent. Okay, I know I'm going fast, but that's the joy of a video. You can pause and look through it. Okay, now we have a tangent line. We know we have a tangent line. Okay, so given that we have a tangent line, find the missing piece. So we know we have a right angle. Okay, so we know that C squared is equal to A squared plus B squared. We know that equal is true. Okay, we know these are tangent. Now we're going to use it to find a missing piece. Okay, so remember when we did this? This was C, this was A, this was B. We're missing an A. So go look at the Pythagorean theorem, and I told you how to calculate that. We're missing an A. We take C squared minus B squared under a square root. Okay, so this is back in the Pythagorean theorem section. So to figure out our missing radius, our missing A side, our C is 25, our B is 20. So I square them and put them under a square root. And so my missing A is 15. So my radius is 15. Okay? So this is back in the Pythagorean. This is not new. It looks new, but it's not. Tangent line just means we have a right triangle. So let's go back to the Pythagorean theorem and the converse and figure out what we did before. So we have a right triangle. We know this is a right angle because we know this is tangent. Okay, I'm telling you that right now. It is tangent. So that means this is my C, this is my A, this is my B. I'm missing my A. So from the Pythagorean theorem chapter, we're going to do this. My missing radius is A. My C was 17. My B was 15. I'm going to put that in the little setup that you learned back in that other section. And my missing radius is an 8. Okay. Okay, so 5 is C, A, B. So we're missing an A. C squared minus B squared. So C was 5, B was 4. Put that in your Desmos or calculator just like this. Just type it just like that if you want to. And you get a 3. So my radius is 3. Okay, so now we have tangent lines, and we know if we do or don't. Now let's look at the angles they create. So when I have a tangent line, it's actually the exact same as an inscribed angle. Okay? And an inscribed angle, we learned that whatever this was, we double it out here. So whatever theta was, whatever this angle is, we double it, and that's our arc. Okay? So on the other side of the circle, we have linear pairs. So this is a straight line. Take away this part. So if we need this angle, it's 180. Take away what is over here. Okay, so if you write this down, it then just becomes a map. So whatever you're looking for, you can figure it out based on where it is on the picture. Okay, so write all these down, and then it just becomes an easy way to check and put the numbers in your picture and figure out what you need. Okay, so let's take a look. So it says arc NOP is 240. So arc NOP, arc NOP. So it's this one right here. Okay, 240. Find angle N, or sorry, find arc NP. Well, NP is the smaller one right here. Look, we have a whole circle. The red part's 240. We have to figure out the blue. Right? Well, we know a whole circle is 360. So why don't we just subtract the part that's in red so we can figure out the blue part, right? So if we subtract what we've got, it means the blue was 120. So NP, arc NP is 120. to find angle NPS. N, bend at P, goes towards S. NPS. So this one is NPS right here. Okay? We know the rule is whatever this is double whatever it is. So in this case, 2 times that angle is 240. So which means the angle by itself is half of that. It's 120. Okay? Right? Then the last one is find angle NPR. Okay? Angle NPR. So this side right here. This is NPR. So we can do the same thing. This one is going to double to create that one, right? That's how they work. We also know that this one and this one should add up to a straight line, or 180 take away. Okay? So on our picture on the previous page, we said take 180 minus the one from the other side equals 60. Or if you did the angle, the theta method, the purple 2 theta equals 120. So it means that angle should be 60. So either way, you end up with 60. So whatever way you like to do this, you have choices. Let's look at another one. Okay. Angle NPR is 57. NPR. NPR is right here. That's 57. So remember, on our picture, it's theta, 2 theta, 180 minus theta, right? And 360 minus 2 theta. There's our map. Okay? So arc NP is 2 times whatever this was. It's 114. Okay, angle NPS here on the other side is 180, take away that angle. So 123. And then arc NOP, this big arc, is 360 minus the 2 theta part. 360. The 2 theta was 114. So 246. And that's how you do it. If you have the map, you put in your number to figure out how to get to the rest of them. They're all related to each other. And that is it for this section.